us yesterday, I think you'll still be fine today, like learning something new. I don't think you necessarily fully need it. I think knowing what we did yesterday is definitely going to help. So hopefully, like as I go through the examples, you catch on. But today you're going to learn about reference triangles still, but what we're going to do is we're going to incorporate SOHCAHTOA in there. So sine, cosine, tangent. We'll also do the reciprocals, which really aren't much different. They're just flipping fractions. And we're going to continue to calculate standard and reference angles. The difference is, yesterday we had the standard angle and we were finding the reference angle. Today we're going to have the reference angle and we're going to find the standard. The idea is the same, the concept, the relationship is the same. It's just we have the other one. So we are going to be in our toolkits on page 2. All right, so when we start to incorporate sine, cosine, and tangent in 4 quadrants, we're going to use this acronym, ASTC. Okay, here's how I remember ASTC. All students take calculus. Okay, if you can remember that statement, all students take calculus. It's like when you were little and you were remembering north, west, south, east, right? Like never eat shredded wheat, or what did you guys? Never stop wandering. Whatever you guys use for that, all right? So, all students take calculus. Remember that sentence. It'll help you with the letters, and then I'll explain to you what the letters mean. So, when you are looking at quadrants, remember quadrants go counterclockwise. So the A is going to fall in quadrant 1. The S for the students isn't going to go down. It's counterclockwise. So the S falls in quadrant 2. T, C. So on your toolkit, you've got like a blank coordinate grid. You're going to write A, S, T, C. All students take calculus. Each letter stands for a trig function. S is sine. T is tangent. C is cosine. A is all. The word you're saying, all. Everything. All right? So here's what it means. We are going to start to draw reference triangles, and they're going to fall in different quadrants. Each quadrant is going to have a trig function that's positive and trig functions that are negative. This is when they are positive. So in quadrant 1, if you have a reference triangle that falls in quadrant 1, sine is positive, cosine is positive, and tangent is positive. All are positive in quadrant 1. We haven't done any trig functions yet. So when we start to add them in, we'll need to know if they're positive or negative. This is going to help us with that, all right? If the trig function falls in quadrant 2, only S is positive. So sine is positive in quadrant 2, but cosine and tangent are negative. So this is telling us when they are positive, all right? So what do you think is going to happen in quadrant 3? What's going to have the positive sign? It's T. What trig function's T? Tangent. So in quadrant 3, sine is negative, cosine's negative, tangent's positive. This is not something you'll have to memorize. It's something you can memorize. But just like yesterday, if you're more of a visual person, I'm going to show you why these things are true visually as well. And so you don't necessarily have to memorize this. I just don't think it's that hard of a thing to memorize. All students take calc. Think of the letters, and that helps. All right. So in the 4th quadrant, cosine's the only one that's positive. So sine and tangent are negative. You okay with that? All right. So we're going to use this. All right. It's going to be on the next slide. It's still here. All right. This is not anywhere in your notes. It's just a talking point. All right, so you're eventually going to start to be given information, and instead of giving you an angle, instead of saying graph the angle of 100 degrees and you finding where that is, you're going to be given information and you have to decide where the angle goes, right? So think about these 2 pieces of information. Sine of theta is greater than 0, cosine theta is less than 0. So what does that mean? If sine of theta is greater than 0, what this is saying is that the sine is positive, right? Because greater than 0 means it's a number bigger than 0. Numbers bigger than 0 are positive. cosine theta is less than 0. Well, that means that cosine, let's do this in a different color. This means that cosine is negative, because being less than 0 is going to be a negative number. You with me so far? Okay, so I use ASTC for this. And I ask myself, well, where is sine positive? Sine is positive in A, because everything's positive in A, and S, because sine is positive in S, right? So if you really look at it, look, sine is positive here, and sine is positive here. All and sine is positive. Sine's negative here, and sine's negative here. So it's not going to be something in quadrants 2 or 3. Because if sine's positive, I'm in 1 or 4. And then cosine is negative. This one you have to do a little bit of thinking, because all students take Calc tells you where things are positive. So cosine is positive in 1 and 4. So in turn, that would mean it's negative in 2 and 3. And so if I have these two pieces of information, I know that my reference triangle is going to be something in quadrant 2, which tells me a lot about it. It tells me that my angle is somewhere between 90 and 180 degrees. It tells me exactly what my right triangle is going to look like, because I know what x-axis I'll use, right? So I'll be able to work through it, right? So this is me figuring out my quadrant without having an angle at all. Let's look at another one, right? So, again, not in your toolkit. I'm just using the information I'm given. Sine of theta is less than 0. So what that means is the sine is negative, because less than 0 means it's negative. So let's think about where sine is negative. All students take Calc tell us where things are positive. Sine is positive in A, because everything's positive in A, and it's positive in S, because sine is positive in S. So if these are the two places sine is positive, and I'm looking for where it's negative, I would pick the other two. Are you okay so far? Okay. And then this one's saying tangent of theta is less than 0, which means tangent is negative. All students take Calc tell me where it's positive. Tangent is positive in A. Everything's positive in A. And T, because tangent's positive in T. But I don't want tangent to be positive, I want it to be negative, so I'm going to look at the other two places. The thing they have in common is quadrant 4. So my answer, my reference triangle, is going to fall somewhere in quadrant 4, which tells me that it's some angle between 270 and 360. Because that's what I know about the angles in quadrant 4. Make sense? All right, so try it. Here's your information. Tangent of theta is greater than 0. Sine of theta is less than 0. You can work through it in your head. You can jot something down. It's not in your toolkit. We want to figure this one out. Anyone figure it out? It's the third quadrant. Okay, so sine of theta is tangent theta is positive in 1 and 3. And sine is negative, well, it's positive in 1 and 2. So it's negative in 3 and 4. And the overlap, what they have in common, is 3. We okay with that concept? Again, when we do the actual examples, they're going to be more visual. They're going to have numbers to them, and you don't necessarily have to memorize this, but it does help to know it. So I thought it was important to talk about it before. All right. So on your toolkit, example 19. I think it's right after the ASTC. All right. It says, let theta be any angle in standard position. So standard position is the ones that you've been graphing, like graphing 100 degrees and knowing that's in quadrant 2. Graphing 290, knowing that's in quadrant 4. That's your standard position. So we're looking for some angle in standard position whose terminal side, which is its ending side, goes through the point -5, 3. Find the 6 trig functions, find the reference angle, find the standard angle. So let's see what we know. Our terminal side is going to go through the point -5, 3. All right, so -5 1, 2, 3, 4, 5, positive 3. So I'm going to make a point at negative 5, 3. And I'm just going to make this a terminal side. Remember, the terminal side goes from the 0, 0 to, we just kind of draw it out in the open. Now we're going to draw it to that point. That's my terminal side. All angles have the same initial side. That's this one. This angle from here to here is called the standard angle. I know something about the standard angle already. I know that it's somewhere between 90 and 180 because it falls in quadrant 2. So when I finish this whole problem up, if that red angle is not between 90 and 180, something went wrong. Does that make sense so far? Okay, so now that I have that, I'm going to draw the reference triangle. Yesterday, if you weren't here, this is what we talked about. A reference triangle, you use the x-axis. Sometimes you'll use the x-axis on this side, and sometimes you'll use the x-axis on this side. It depends on where the ending result falls. So because my ending angle is in quadrant 2, I'm going to use the x-axis in quadrant 2. I'm going to use that one. If this was in quadrant 1 or 4, on the right side, I'd use the x-axis on that side. And then we just drop a line straight down from the red to the blue. And that's called the reference triangle. It is a right triangle. And anytime you have a right triangle, you can use right triangle trig, SOHCAHTOA. All right? So let's think about what we know about this right triangle. Well, we went over 5, right? So the length of this side length is 5. And we went up 3. We didn't go diagonal 3, right? We went up 3. So this is my 3. Does that make sense? Like the height of the triangle is 3, not the hypotenuse. So I went up 3 and over 5. Now technically, sides of triangles can't be negative. The negative is just the direction. There is a negative on this 5 because I went to the left 5. There's not a negative on the 3 because I went up. That's the positive y direction. However, in terms of the triangle itself, a leg of -5 does not make sense. You can't take out like a tape measure and get a -5. So when we're talking length, it's 5. When we're talking direction, it's -5. Does that make sense? All right, so we've got a right triangle, and we've got 2 of the legs. I can figure out the red one using Pythagorean theorem. So we're going to use Pythagorean theorem to find the hypotenuse, right? So we're going to do 3 squared plus. Now you can do -5 squared. You just don't have to. If you're going to do -5 squared, you just have to use parentheses. The calculator will not read it right as like a negative. All right, so that's going to be my hypotenuse. So we've got 25 plus 9. Is that 30?
Wait, why'd you do -5?
You don't have to, you can. Like, look, when I put it in the calculator, as long as I use parentheses, it doesn't matter. The -5 is the direction, but it's still going to give me 34 regardless. You just have to make sure you use the parentheses, otherwise it won't give you 34. All right, so I've got 34 is my c squared. So the actual hypotenuse is the square root of 34. If you end up with something here that is something you can reduce, like something that divides into 4, or something that divides into 9, something that divides into 16, you should break it up. 34 does not have any perfect square factors though. So I'm just going to leave it as a root 34, but now I know the hypotenuse. Okay so far? Okay, well sine, SOHCAHTOA, sine is opposite over hypotenuse. So I'm going to take the opposite side length, which is the opposite of the reference angle. This green angle right here is the reference angle. So I want to do the opposite of that angle. The opposite of that angle is 3. And the hypotenuse is root 34. Is everybody okay with why I did that? Sine is opposite. So opposite of this angle is 3. Hypotenuse is the diagonal, that's 34. Sine is opposite over hypotenuse. This one, some of you forgot this on the quiz. I paired them perfectly next to each other for a reason. All I have to do to get this is flip that. Cosecant is the reciprocal of sine. So reciprocal just means flip the fraction. So this one, I'm going to flip the fraction. Same numbers. Now, I can't have a denominator with a root though. I'm going to rationalize that one. We okay with rationalizing? I'm going to multiply by root 34 over root 34. So I'm going to get 3 root 34 over 34. Not the end of the world if you don't rationalize, but you should. Like you'll maybe lose like a half point on a quiz if you don't rationalize. I really care, do you understand the concept of opposite over hypotenuse more than I care if you rationalize it or not. Alright? So cosine is adjacent over hypotenuse. This is where all students take calculus can or cannot come in, depending on how you feel about memorizing it, all right? The adjacent side is -5, but maybe you forget to write the negative, and then all students take calculus will come in at the end and save you from that, all right? So I'm going to do it with the -5, and then I'll show you why it is -5. So cosine is adjacent over hypotenuse. And secant is just the reciprocal of that. I like to flip before I rationalize. It saves me time. All right, so that's why I'm flipping that. And then because this one has a root in the bottom, I'm going to rationalize it. So that's the ka, and so patella. And then tangent is opposite over adjacent. So the opposite leg is 3 and the adjacent leg is -5. And then I'll flip that here. We okay so far? Now let's say you didn't write the -5. You just thought it was 5. Here's where all students take Calc comes in. Well, I'm in quadrant 2. And quadrant 2 tells me that sine is positive, cosine is negative, and tangent is negative. So I need to make sure this ends up being something that's positive, which it is. I need to make sure that this ends up being something that's negative. So if you forget the negative, you can just add it now. It's supposed to be negative, so let me throw the negative in now. I had the negative, but if you forget it, you can put it in at this step. Tangent should be negative, and so if you forgot this negative, now you'd add it in. So that's why all students take Calc helps with that. It's only if you're missing the symbols. Everybody okay so far? I want to solve for my reference angle. I can use this, this, or this. Which one looks the easiest? Tan doesn't have any roots, okay? So, to solve for the reference angle, I want to solve this equation. How do I get rid of tan and just get theta? Inverse of tan. So I'm going to do the inverse of tan here. But here's the catch. When you are doing tan inverse, you are working with a triangle. When you are working with a triangle, you're working with side lengths of a triangle. It doesn't make sense for side lengths of a triangle to be negative. So when you enter this in the calculator, you don't want to include the negative symbol. If you include the negative symbol, you're going to get a negative angle. A reference angle shouldn't be negative. So just keep in mind that right triangles have positive side lengths. That -5 is just giving you direction. It's not giving you a side length. So I'm going to do the tangent inverse of 3/5. Just make sure your calculator is in degree mode. Mine's in radian mode right now. So if I do the tangent of 3/5, I'm going to get something weird. So I'm going to make sure I'm here. And tangent inverse of 3/5 gives me this. If I do the tangent inverse of 3/5, you see it's really similar. It's just negative. Okay? The reason it's negative is because that's giving you direction. You don't want the direction. You just want the angle. So the reference angle is we'll call it 96 degrees. So this angle right here is 30.96, but I want the red angle. Well, what's the relationship between the red and the green? 180. So I know that my reference angle plus my standard angle equal 180. We're used to having the standard angle and solving for the reference, but it works the same way, right? So I know that this is 30.96, and so I can solve for x. I can subtract the 30.96 from the 180 and get x. What is it?
149.04.
49.04. Remember what we said about this angle in the beginning? It's in quadrant 2, so it should be something between 90 and 180. And it is. Look at you guys, you're doing great. What do we think? Let's try another one.
I think Colin's ready for the test.
Let's try another one. All right. Let theta be any angle in standard position whose terminal side contains the point 2, -6. We want to find all these things. All right. So let's go to -6. And I'm going to connect that from the middle. The end and goal, the very last thing we're going to do is figure out what that is. It looks like it's going to be something just over 270, just based on my picture. Somewhere between 270 and 360. So keep that in mind when we get there, but that's the last thing we do. We okay so far? Plotting a point, drawing a line. Now, reference triangle. You weren't here yesterday. Because this is on the right-hand side, I need to use the right-hand x-axis. So I'm going to use this part. Whereas when we're in quadrants 2 and 3, we have to use the left-hand x-axis. And then I'm just dropping this straight down. This is my right triangle. That's called a reference triangle. The corner angle is called the reference angle. So this angle right here is what this is. Let's think about what we know about the reference triangle. We went to the right 2. So that length is 2. And we went down 6. So this length is 6, but because we went in the down direction, I'm going to put a negative on it. If you forget the negative, it's not the end of the world. You can get it at the end. The key is that you know we went right 2 and down 6. That's the legs of the triangle. So we can figure out what the hypotenuse is, right? Pythagorean theorem. So 2 squared plus 6 squared. This time I didn't include the negative. All right, just showing you that you don't have to include the negative. So that equals c squared. So I think we end up with 40, right? So
410.
Yep, we got to split this one up.
So 2.
Yep, 2 root 10. So we're going to do root 4 root 10 or 2 root 10.
When we put it in the sign, are we simplifying the fraction?
Yep. I said 10 and I wrote 6. All right, so the hypotenuse is 2 root 10. Pythagorean theorem. We okay with that? All right. So now we're going to do SOHCAHTOA. Sine is opposite over hypotenuse. Opposite of the green angle. Opposite of the green angle is -6. Hypotenuse is 2 root 10. And then I'm going to flip that. 2 root 10 over -6. You can reduce this to 1/3. So like, I'm just reducing the fraction there. And then for the sign, I'm gonna rationalize. I can't have that root 10 in the bottom. So I'm just rationalizing it out. What does the bottom become when I do 2 root 10 times root 10? 20. It's 2 times root 100, which is 2 times 10. So the bottom becomes 20. And I can simplify this. I'm going to try to squeeze this up here. Negative 3 root 10 over 10. You play simplify in the beginning, yep. I think it's still kind of the same number of steps, but yeah, you can do it at the beginning or the end. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So 2 over 2 root 10. Secant's just flipping that. The 2's cancel out. So it's just root 10. But I have to rationalize that one. If you guys are stuck on the rationalizing, let me know. I'm going through it fast because we've been rationalizing already in the previous unit, so I'm kind of going through this part fast, but I can talk about what I'm doing if you need me to. I'm just reducing fractions. I'm getting root 10 over 10 for that one.
When you're rationalizing the denominator, or you just
I'm just
multiplying the root 10 by root 10?
correct, which is root 100, which is 10, and then that 2's just coming along, and so it becomes 2 times 10. It's obviously much easier if it's a root that doesn't break up, but if you have that, you just carry that through. And then tangent is opposite over adjacent. And I can simplify that to negative 3 or negative 1/3. And let's say you forgot the negative on the 6 and you just had it as a regular 6. You could do all students take calc. We're in quadrant 4, so cosine should be my positive one, meaning that sine and tangent should be negative. So I'm just going to go through and make sure that that's true. Sine is negative, I've got a negative on it, but if I didn't, I would add one now. Tangent is positive, I have that as positive, so that's good. Cosine's positive. Tangent is negative, if you forgot the negative, you would just add it at the end. So all students take calc is just like a check. You don't necessarily have to do it, it just helps you with the symbols in case you miss one. So for the reference angle, I'm going to use one of the 3. Which one looks the easiest?
6 over 10.
The tangent, right? When I do the tangent inverse, I'm just going to do it of 3. I'm not going to do it of negative 3. You'll see why. If you do negative 3, you're going to get a negative number. We don't want negative numbers. When we're referring to tangent, we're referring to triangles, and triangles don't have negative side lengths. So I just ignore the negative. And I'll show you, it's the same thing. You just have a negative there. Okay, so we don't need the negative. So my reference angle is 71.57, we'll call it, if we're rounding it to 2 decimal places. 71.57. That's the green angle, but we want the red. So what's the relationship between the red angle and the green?
You have the minus of 536.
Together they make a 360, right? Together the red and the green make this full circle. So my reference angle plus my standard angle equal 360. What we were doing yesterday was solving for R, but today we have R, and we're solving for S. The process is the same. So I would just subtract 71.57 from 360. That's not right. Oh, I did the one before it. Thanks. Just gonna pull it up. I just did the wrong minus. Alright, so 288.43. Remember in the beginning I said, just kind of looking at it, it looks like it's going to be something really close to 270 because of how close it was to the axes. But I know it's going to be somewhere between 270 and 360. So that is what do you guys think? It's a lot, but it kind of brings it all together. So tomorrow I'm not in. So I'm not going to leave you with like anything new. I'm going to leave you with practice on finding coterminal angles. So if I give you a negative angle, can you tell me what that looks like as a positive angle, right? Drawing reference triangles and finding reference angles like we did on this today, which I think you guys did great on. And then a few practice of this. So you can practice that and be good at that. And then when I come in on Thursday, we'll do something new. We're going to add something new to that. All right, so tomorrow is just practice, but we're turning over a new leaf. So even though it's a sub, we're not going to just not do anything. You're going to try it, okay? I think there's like 15 problems, but some of them are like draw a reference angle. So it's quick, okay? So I'm asking you to do that. I will have the key posted on Canvas. I will have the key posted on the backboard, and I will have a video explanation. So those of you that weren't here yesterday, if you need more help with the reference part, I'll have a video for that, all right? And then you'll have the rest of class to work on. There's a new Delta Math. I decided that for this Delta Math, to give you examples. So I worked through my own Delta Math and I wrote out the examples. So if you get stuck, you have a hard copy example to look at. All right? Any questions for me?
No.
All right.
Do you have a test this week?
We do not. Your test is next Tuesday, a week from today. Okay?